Hello and welcome to class. I'm Lavinia Heaton, and today we'll be looking at linear functions and slopes. Now we already know what a function is, and we might guess that with the word linear there that we're talking about a line when we do the graph of the function. But to begin with, we're going to talk about the slope, and then we'll see what the equation of a line might look like. So let's pretend that we're going climbing. Here's our ground. And then we have a choice of climbing right here to this height, or we can go right here and get to the same height. Would you have any preference then in which mountain you chose? Would you choose the one on the left or the one on the right? Now, I would choose the one on the right because I'm not particularly athletic. Someone who's more athletic might like the challenge of the one on the left. Well, what makes the difference? The difference is the steepness. The one on the left is much steeper than the one on the right. So that makes our decision. As we move from one point on the mountain to another point on the mountain, how much we go up as compared to how much we go over determines how steep it is, because here we go up and over very little, but we're going up here and then over a lot, and that makes a difference. In math, we call that slope. So we use the letter M for slope, for the French word monter, which means to mount or to climb. And we'd say we're comparing the rise and the run with the rise on top and the run in the denominator of our fraction. That's the way we've decided to do it. Now let's say we name these points as if they were on a graph board here, and we call this one right here our first X and our first Y. We come up here and call this our second X and our second Y ordered pair. Then when we rise, only the Y's are changing. When we run, only the X's are changing. So the distance that we rose would be the difference in Y sub 2 and Y sub 1, and the difference in what we ran would be the difference in X sub 2 and X sub 1. Now, it's very important that we match up Y sub 2 and X sub 2 when we do our slope here. Okay, so this is actually the slope then. So let's go back here and write that slope formula down. Our slope is going to be M equals Y sub 2 minus Y sub 1 divided by X sub 2 minus X sub 1. Okay, let's look at a problem that goes with this. So going back, problem number 1, we'll find the slope of the line passing through the points 6, negative 4, and 4, negative 2. Here's our first problem. I've written down the 2 points, 6, negative 4, and 4, negative 2. And remember our slope formula. The slope is Y sub 2 minus Y sub 1. So why don't we label these so that we know which is Y sub 2 and which is Y sub 1. Okay, we'll label this point our first X and our first Y. This point our second X and our second Y. So then the slope is Y sub 2, which is minus 2. Then we have minus in the formula. But then Y sub 1 is negative, so we've got minus in the formula and then negative 4. So don't get mixed up and put just one minus here because 4 is negative. No, you've got to have 2. And then X sub 2 is 4 minus X sub 1, which is 6. So the slope then is negative 2 minus a minus is plus 4, and 4 minus 6 is negative 2. So then, continuing on, 4 minus 2 is 2. In the denominator, we still have negative 2. And then we think positive over negative is negative. 2 divided by 2 reduces to 1. So our slope is negative 1 for this problem. Well, we have a similar problem coming up next. The 2 points this time are 4, negative 1 and 3, negative 1. So we start with m equals, we want a y sub 2 and a y sub 1. So let's label our points again. First x and y, second x and y. So y sub 2 minus 1, minus in the formula, and then minus 1 for y sub 1, divided by x sub 2, which is 3, minus 4. So m equals negative 1 plus 1 divided by 3 minus 4. Let's go ahead and simplify that. 3 minus 4 then is negative 1. So I now have 0 divided by negative 1. Oh my. Do I have an undefined situation here? I've got 0. I think we better try dividing and see what happens. So let's go back to our pad, and we have 0 divided by negative 1. Yeah, I've got an answer, and I've got just one answer. 0 times negative 1 is 0. So this one is defined. It's actually 0. So we have ended up now with our slope m equals 0. And that's okay for a slope to be 0. Let's say we're going from this point, we rise none, and we run some. We just have a horizontal line, don't we? And that slope is 0. It's not hard to walk on even ground, is it? Well, the question comes up. We've been doing y sub 2 minus y sub 1 divided by x sub 2 minus x sub 1. Well, I have a question for us. Let's go back to our slope formula. I wonder if these are equal. Could I say y sub 1 minus y sub 2 divided by x sub 1 minus x sub 2? Would that work? Well, let's go to this problem right here where we computed the slope to be negative 1. And let's change it so that we're using that other formula and just see if we get the same answer. So we start here with y sub 1, which is negative 4, minus in the formula negative 2 for y sub 2. Then x sub 1 minus x sub 2. So we have negative 4 plus 2 divided by 2. We get negative 2 divided by 2, which is negative 1. And if you'll recall, that was our answer just a few minutes ago, negative 1. So it seems to be true. Now, because it's true in one case doesn't mean it's true in all cases unless there's something we can do to show that. So looking back at our slope formula here, is there a way to get from the blue to the red? In all cases, will it always be true? Let's start with the blue again. Y sub 2 minus y sub 1 over x sub 2 minus x sub 1. And let's do our red again over here. We have y sub 1 minus y sub 2 divided by x sub 1 minus x sub 2. Now my question is there something we can do to this to turn it into this every single time? Notice, if you haven't already noticed, that the sign of y sub 2 is positive here but negative here in the formula part. And then we have minus y sub 1, but plus y sub 1. So it looks like I could get from here to here by multiplying by negative 1, doesn't it? Let's try that. Distributive. Negative 1 times y sub 2 is negative y sub 2. Doesn't matter that I write it second, it's still negative y sub 2. Negative 1 times minus y sub 1 gives me plus y sub 1. But you know what? If I multiply my money by negative 1, I am not going to be happy at all. If I've got $30, I don't want to have negative $30 all of a sudden. So what I need to do, if I want to multiply the amount of money I have by something and keep the same amount, I would use the identity for multiplication, which is 1. Well, I'm wanting to use negative 1 in the numerator, so if I use negative 1 in the denominator, then I will have multiplied by 1 in a form that will help me out. Let's check it. Negative 1 times x sub 2 is minus x sub 2. Minus 1 times minus x sub 1 is plus x sub 1. So we can see here, no matter what numbers we use for x sub 1, y sub 1, x sub 2, y sub 2, and whichever way we subtract, we can come up with them being equal slopes. If you noticed here, it was negative 2 in the numerator, and a few minutes ago we had 2 over negative 2. So there is a little difference in the workout, but the same ratio ends up reducing to the same ratio. So going back, we can conclude that we can do it either way. But usually we get set on just one way and use it. And I like y sub 2 minus y sub 1 because I'm in the habit of using it. Therefore, to me, it's easier. Okay, let's think about this now. What if I took the slope formula and doctored it up a little bit so that I had just a general or arbitrary x or y in it? For instance, let's draw us a line here, and we're going to have 2 points, a point here and a point here. And like we usually do, I'm going to call this my first x and my first y. But up here, instead of naming this point, I'm just going to say it's a general one. When I subscript a point, it's like I have identified it as a certain location on the line for this particular problem. An x and a y that's general means that point could be anywhere up and down the line as far as the line goes. So that is acting in the place of my x sub 2, y sub 2 point, isn't it? So let's look at the slope here. The slope is y sub 2, which in this case is y, minus y sub 1, divided by x sub 2, which in this case is x, minus x sub 1. And there we have what we call the point slope form of the line. We had a given point, and we're going to say that the slope of that line was m. And with a given m and a given x sub 1 and y sub 1, we can come up with a general x and y in the equation of the line. Now, I don't know about you, but I'm not as fond of fractions in the formula as I would be if I had a formula without fractions. So I'm going to give myself a little space here to write. And I still didn't do it right. Let's erase it all here. Go back and put m equals, we had y minus y sub 1 divided by x minus x sub 1. Now I want to clear the fractions. Now think with me a few minutes. What does it take to clear the fraction here? Well, let's see. If I had something right up here that would divide out this numerator and the denominator x minus x sub 1, what would it be? It would be this x minus x sub 1, wouldn't it? Now they will divide out, won't they? 1 over 1. And I won't have a fraction anymore. The problem is I've done something to one side without doing it to the other, and that won't keep it balanced. So I'll have to do the same thing over here. A few minutes ago we multiplied by 1 just because we were trying to change our fraction to another looking fraction that was equivalent. Here we're trying to clear fractions, so we're going to do something to both sides of our equation. I can't just haul off and get rid of fractions because I want to. It has to be in an equation or an inequality so I can do the same thing to both sides. If I don't have an equals or a less than, something like that, I don't have both sides to work on. Okay, so now I've reduced that, and on the right side I have y minus y sub 1. On the left side, I have x minus x sub 1 times m, and I'm going to use commutative property of multiplication to switch the order of my factors, because I just like to look at my m first, okay? And then, what if I switch left and right sides? Then I would have y minus y sub 1 equals m times x minus x sub 1, wouldn't I? All right, that is called the point slope form of the line. So let's go back to our page 1 and list that with our slope formula. Point slope form of a line is y minus y sub 1 equals m times x minus x sub 1. Okay, in the next session, we will be looking at some problems which use this formula. We have found the slope formula for a line, and we've seen how we can plug it in and come up with the point slope form of a line, and we will be looking at that in the next session.